Hello, Lovelace, and welcome to the second part of our science for this week. If you remember last time, I asked you to invent or create an investigation, a fair test that would find out what the strongest paper in your house is. Now, hopefully you've completed that investigation. If not, there is still chance, and then you can do this lesson afterwards. But this lesson follows on from the first one. So if you've not completed the experiment, you'll need to do that first. Okay. But moving through. Okay. So for this lesson, you need to be able to make a scientific prediction. Now, actually, you've probably made the prediction already, but we're going to come back to that. You need to explain how you've kept your test fair. We talked about that last lesson, but we'll recap on it again today. And you need to be able to record your findings and make a conclusion. Okay? So today is all about working through a scientific write-up. Now, this is really useful information and really useful language because over the course of your school life, as you move through secondary school, you'll do lots of scientific investigations and you're going to need to explain them in a clear and scientific way. So this is good practice. So as we said, last lesson, you were set the challenge of testing the strength of different types of paper. And today we're going to write up our test as a scientific investigation. We're going to need a question. So what were we trying to find out in our investigation? We need a prediction. Hopefully you made that before starting your test. What did you think was going to happen? We need to explain our method. What did we actually do? What did our test look like? Okay. And how did we make it fair? Now, scientists will often include a diagram in the method. This helps the reader understand what's going on and picture the test. We need results. We need to know what we found out. What did we observe? What did we measure? Okay, for this one, it's probably the amount of weight the paper was able to take. But it may be a different number altogether, but we need to measure something and give our results. And then finally, a conclusion. What did we find out? Now, usually, or quite often, this can just be the answer to the original question. Okay? So we need to wrap it all together. We start with the question, we finish with the answer, and the bit in the middle is the finding out. Okay? Right, so let's work our way through. Now, I'm going to take you through an example of how we do the write-up, but this is for my investigation. I did this test as well. Yours might be different, okay? So I'm happy for you to copy the format, okay? But you need to write about your own experiment. You should be explaining what you did in your test, but in the same way that I did, okay? So follow my plan, but make sure you're writing about your own test. First up is the question. So my question is, from a sample, which type of paper is the strongest? Okay. Now, I could have written just which type of paper is the strongest, but I chose to put in that statement from a sample. And I chose that because I haven't tested every single type of paper. I asked you to find 5 different types of paper around the house. So that's not every piece of paper that exists. So I said from a sample. You might have said from my sample or from the 5 I tested. Something that makes the reader realize that you've only tested a small number of paper types. You've not tested every single type of paper in the whole wide world. Okay, so a little phrase in there just to make the reader realize, okay, this is a small sample. So our question, from a sample, which type of paper is strongest? Next, we need the prediction. Now, I made this when I cut up all my paper, or found all my paper types. I laid them in front of myself and I took a look. And I thought, from my sample, I think the cereal box card will be the strongest. Okay, that was one of my 5. And so I think that one was going to be the strongest. We'll find out from my test if I was right or not. after the prediction, okay, so as I say, that should have happened before we started the write-up. Next comes the method. What did we do? Okay, think of this as a set of instructions for someone else to follow. Imagine if you just gave your write-up to another scientist and said, go away and do the same test that I did. It should be like a set of instructions. It should be really clear what you did, the order you did it, and so someone else could understand and do that same test. Okay. Now you might choose to draw a diagram to help you explain. What I've done, I've inserted the photographs I took, okay, because it's quite tricky to draw on the computer. So I'll put the photographs in, but you can do a picture of what you did, sort of showing the setup, showing the pieces of paper, showing the weights or anything else that you did. To keep my test fair, I cut all the samples of paper to the same size. Now for me, that was 12 centimeters by 3 centimeters. I made strips of paper. I didn't want them to be too wide because I didn't want them to be too strong. I thought if I make them too strong, we could be there all day with massive weights. So I made the paper quite small. But by making all the paper the same size, it helps to make my test fair. I taped a paper clip to the bottom 1 centimeter to act as a hook for when the weights, and I held the top 1 centimeter between my finger and thumb. This left 10 centimeters of each paper to test. Okay, so I'll show you the photograph in a moment, but if you can imagine, the top 1 centimeter is for holding, the bottom 1 centimeter allows me to attach my weights, and so it's the middle bit that's going to get stretched until it rips. Onto the paperclip hook, I placed the fabric bucket to hold the weights. I had a little rummage around the house and I found some sort of container that I could put the weights into. I know in the example one, in the last lesson, the boy used the bucket and water. I decided that water was too messy, so I just found another type of bucket. This was just a fabric one to hold my weights. One by one, I placed pebbles into the bucket until the paper ripped. I recorded the number of pebbles needed to rip the paper. Okay, so again, looking around the house, actually just outside the back door, I collected some pebbles, and they became my weights because I didn't have any measuring weights around the house. I just needed some objects that would be heavy enough and that I could count into the bucket. Now, you might be thinking that all the pebbles might be different weights, and you'd be right. So I put the pebbles into the bucket in the same order for each piece of paper. So each time they were going up by the same amount of weight. Okay, I hope that makes sense, but I was very, very careful to make it fair. So pebble 1 was pebble 1 for all 5 different types of paper. Pebble 2 was the same for all 5. Okay, so that's how I made it as fair as I possibly could. Okay, so here are my photographs. I started with my 5 different pieces of paper. I've got the cereal box card. I've got toilet paper. I've got printing paper, kitchen roll, and then a piece of magazine paper. There's the setup. So you can see finger and thumb in the top centimeter, and I've taped in the bottom centimeter a paperclip hook, and then 10 centimeters of paper is there to be stretched and torn as I add the weight. There's the fabric bucket I just found lying around. I think it was from an old Halloween for collecting sweets in. I'm not sure really, but I found it lying around the house and it was a perfect container for me. And then there are my pebbles, and I would add them in the same order each time to make the test fair. So there's my method. So the results. So the results are where you show what you recorded. In my case, how many pebbles. You might have used water or pencils or Lego bricks or anything at all as your weight, but you should have recorded how many or how much weight each paper would take. Now, usually, scientists would show their results in a table or a graph, but as long as it's clear, it's up to you. I've done both so you can see the difference. There's a table. So here, the different types of paper, and I've listed the 5. Remember, toilet roll, kitchen roll, printer paper, magazine, and cereal box. And there's how many pebbles it took before it ripped. So the toilet roll, after 4 pebbles, it ripped. Kitchen roll was 8, printer paper 9, magazine 7, and the cereal box, I thought it was never going to rip. But eventually, after 36 pebbles, it broke. Okay, so that's as a table. I also did it as a graph. Again, you can see. So you can see that the cereal box is clearly the tallest tower, with the printer paper next, kitchen roll just beating the magazine, and then the toilet roll as the weakest of all. So there's my results. Finally, we need a conclusion. Remember, this is sort of going back to that original question. So from my sample, again, we're just reminding the reader that we have not tested every single type of paper. From my sample, I found that the cereal box was the strongest type of paper. Okay, this is simply the answer to that original question. So your task for today is to write up the investigation that you did. And if you've not done it already, then here's a chance to go away and try yourself. Try 5 different types of paper to the ones that I did. Use different weights. Anything you find lying around the house. Maybe you've got a lot of felt tip pens and you could use felt tip pens as your weights. Maybe there's something in the kitchen. Pasta, for example, or how many, I don't know. I mentioned Lego bricks, or how many balls of plasticine, if the plasticine's all the balls are the same size. Have a think, have an explore. But whatever you chose as your weight, that needs to be explained in your personal investigation. And your write-up, this is what I want you to put onto tapestry for me. This is what I want to see. You should include the question. So what are you trying to find out? Remember, you're not testing every single type of paper. So mention that in your question, that you're just doing the 5 that you're testing. A prediction. What do you think will happen? You should have made the prediction before you started. Look at your papers, paper types, and try and decide which is the strongest. Your method. Remember, this is like a set of instructions. Include in there what you did to make it fair. So I'm sure you all cut your paper to the same size. I'm sure you used the same equipment, the same setup. You held the paper in the same way. You added the same types of weights, and so on and so on. What did you do to make it fair? And draw me a picture. Let me see how you did it. Or include a photograph. Your results. What did you actually observe? What did you count? What did you weigh? And so on. So how many Lego bricks? How many pebbles? How much water? So what did you actually measure for each type of paper before it ripped? And then finally, a conclusion. What did you find out? What was the answer to the question? Was your prediction correct? Did you make a good guess as to what the winner was going to be? Okay, so 5 sections to your write-up. Please make sure you present it neatly and clearly. And then I look forward to seeing these on Tapestry in the next couple of days. Okay, that's the end of today's session. Thank you for listening, and I hope you enjoyed doing your experiment. And I really hope you didn't make too much mess. And if you did, you tidied up after yourself. That's the end of today. Take care of yourselves, and I will see you very soon.